The purpose of this video is to provide an overview of the filter capability within Spectra. For more detail, you can refer to the Spectra reference manual located at our website www.syntheticsound.com.au. Spectra has two spectral filters. The principal design goal of the filters was to give the user highly flexible filtering capability, including the ability for the user to create their own spectral filters. In Spectra, the user can define and use any impulse response within the constraints of 256 harmonics. This ability, together with the ability to specify filter morph sequences, means you may never exhaust the creative opportunities of Spectra's filters. Each filter in Spectra contains 18 built-in filter types and 10 user-definable filters. The preset filters in Spectra are designed to provide a palette of common filter impulse responses for shaping sound. The 10 user-definable filters enable you to specify a custom filter impulse response by drawing it in the editor or creating an impulse response using the filter designer. These will be covered in more detail later in this video. Both filters in Spectra have key tracking, and negative and positive values can be applied. At 0%, no key tracking will be applied and the filter's frequency will be equal to the knob setting. At 100% key tracking, the filter will track to the note played. At 200%, the filter will track an octave above the note played. The envelope amount for each filter enables envelope modulation of the filter's frequency. Filter 1 is pre-configured to use envelope 1 as its frequency modulator, while filter 2 is pre-configured to use envelope 2. These settings can be overridden by keeping the envelope amount knobs at 0 value and configuring another envelope using the mod matrix. The filter envelope amounts can also be modulated by velocity. The velocity knobs enable both positive and negative modulation of the envelope's amount using velocity as the modulation source. Spectra's filters are spectral filters, and therefore they use spectral morphing to transition from a non-resonant filter impulse response to a resonant filter impulse response. The resonant versions of filter impulse responses are denoted with a capital R at the end of the name. For example, 6 dB LPR is the resonant version of 6 dB LP. To configure your own filter impulse response, click on the Filter menu item in the Home or Splash screen. The caption bar in all editor screens displays information about what you are editing. In this case, the caption bar is highlighting we're in View mode. View mode for all editors enables you to see the entire spectrum of all 256 partials at once. In this instance, Filter 1 is being viewed with Partial 1 currently selected. The magnitude or level of the selected partial is also displayed in the caption. On the left-hand side is the level scale. Note that you can alter the level between linear values and decibel values by selecting the decibel option in the lower left-hand corner. You can select any partial by simply clicking on it. To initialize the selected filter to an internal preset value, select the Init button. In this situation, a 24 decibel low-pass filter impulse response has been chosen as the starting point. To begin editing the spectrum, select the Edit button. Note that the Edit screen displays a range of 64 partials relative to the selected partial. The scroll bar at the bottom shows your location within the spectrum and enables you to scroll through all 256 partials. To edit partials, you can select the partial you want to edit and, holding the mouse button, drag the level to the level you desire. If you get to the end of the 64 partial window, pressing the Rezoom button will recenter the currently selected partial. The standard Reason Undo feature also enables you to undo any unwanted edits. You can quickly set a filter partial value to any level in the left-hand scale by selecting the harmonic and then clicking the appropriate value in the scale. To copy a single value across a range of multiple partials, select the partial which contains the value you want to copy. Click on the magnitude value in the caption. Notice how it remains highlighted. This is indicating you are copying the current value. Next, click the selected partial again, and while holding down the mouse button, drag the mouse across the range of partials you want to set to this value. Releasing the mouse button stops the copy process, and the magnitude value in the caption becomes unhighlighted. While editing filter partials, you can set the editor to only apply edits to partials fitting a certain criteria within the partial edit setting. Selecting All will apply your changes to every partial edited. Selecting Non-Zero will only apply your edits to partials which are currently any value other than 0. The Odd setting will only apply your edits to odd partials. The Even setting will apply your edits only to the even partials. Once you've completed, pressing the back button will take you back to the filter view screen. The ability to customize filter impulse responses provides significant sound design capability within Spectra. Here's an example patch developed by Navi Retlev Studios. This patch almost sounds like it has a chorus effect within it. Notice that filter 1 has a user-defined filter. If we go into the filter section of the editor, you can see that the sound designer created this effect by superimposing something like a comb filter over the slope of the filter impulse's cutoff. The Filter Designer screen enables you to draw any filter impulse response within the limitations of 22 draw points. To navigate to the Filter Designer, select the Init button in the Filter View screen and then select the Design button. Editing a Filter Designer point value is relatively easy and intuitive. Simply place the mouse cursor on a point you want to alter, press and hold the mouse button, and move the mouse to the desired location. As you perform this function, the display will provide feedback about the current value. If you make a change and want to undo it, you can use the undo function via the Reason Edit Undo menu item, or alternatively use the key command of Ctrl-Z. In order to add a point while in the designer screen, simply select the Add button in the navigation bar. Note this will highlight the Add button, meaning you are in add mode. Next, select a location within the waveform grid where you want the point to go. Upon releasing the mouse button, the point will be added, the Add button will become unselected, and the added point will become the selected point. If you have already added the maximum number of points, then the Add button will not appear. In order to delete a point while in the Filter Designer, simply select the point you want to delete and press the Delete button. Upon pressing the Delete button, the point will be removed from the design. Note that the first and last points can never be deleted, and that if these points are selected, the Delete button is not available. Also note that the minimum number of points is 2. If a waveform only contains 2 points, then the Delete button is also not available. Every point within a filter design has a line type. The line type enables you to control how the line from the previous point to the current point is drawn. The available line types include line. This line type results in a straight line being drawn from the previous point with an optional logarithmic or exponential curve applied. A curve can be applied to a line by selecting a midpoint and dragging the line to result in an appropriate or user-defined curve amount. Sine P stands for sine positive. This line type results in a sine wave with a positive phase to be drawn from the previous point. Sine N. This line type results in a sine wave with a negative phase to be drawn from the previous point. To change the line type of a point, simply select the point, which will display the current line type of the point. Then select a different line type, either line, sine P, or sine N. The curve of the line will be altered. If you select line as the line type, then you can further edit the line to include a logarithmic or exponential curve to the line. On completion of editing the filter design, pressing the Save button in the Designer screen writes the filter impulse response to the user-defined filter location from where you initiated the designer. After selecting Save, the spectrum is written to the selected memory location, and you can now edit the designed impulse response further using the standard editing features. You may have noticed two additional filter types in the Filter Morph Target pop-up list named fseek1 and fseek2. fseek stands for filter sequence. A filter sequence is a series of filter impulse responses which morph in series. This is a powerful feature which can result in fairly dramatic spectral movement within a sound. Creating a filter sequence is relatively easy. First, set the morph target value in the appropriate filter to fseek1 and set the morph amount to 100%. This will enable us to hear the sequence as we develop it. Next, navigate to the sequence editing screen in the editor. From the splash screen, select the sequence menu item. Before we start creating the filter sequence, it's worth reviewing the elements of the sequence screen. At the top of the screen, you'll notice the caption highlighting we are editing filter sequence 1 and also the mode. The sequence's mode determines how the sequence is controlled. In this instance, the sequence is time-based. You can make the sequence's location modulation-based by selecting the modulated option instead of the time option. At the bottom of the screen are the navigation buttons. The Home button takes you back to the editor's home or splash screen. There are also 4 different morph sequences: sseek1, sseek2, fseek1, and fseek2. The sseeks are spectral morph sequences. These are covered in more detail in the Spectrum Modulators 1 video. The sequences are able to loop, and this can be specified by selecting the loop option. Note that column 2 of the spectrum sequence table displays the loop start, and the last column displays the loop end. Each loop sequence can be from 2 to 10 stages long, with each stage having its own morph time. To add a stage to the sequence, simply press the Length Plus button. You can then specify the spectrum target and morph time. To remove a stage, simply press the Length Minus button. To set the loop start, simply select the stage you want to be the loop start and press the Start button in the navigation bar. Notice column 2 of the selected stage now has an S in it. To set the loop end, simply select the stage you want to be the loop end and press the End button in the navigation bar. Notice that the last column of the selected stage now has an E in it. Changing the spectrum of the sequence stage can be achieved by clicking on the spectrum cell of the stage you want to edit and dragging the value to the appropriate value. Modifying the morph time of the sequence stage can be achieved by clicking the morph time cell of the stage you want to edit and dragging the value to the appropriate value. In this simple example, I've created a filter morph sequence which morphs from 6 decibel low pass to 6 decibel low pass resonant, to 12 decibel low pass resonant, to 24 decibel low pass resonant, then to a 12 decibel high pass, to a 12 decibel high pass resonant, and finally to a notch and notch resonant filter within a loop. I'm going to use sawtooth waves in the generator so that you can easily hear the filter morphing. Note that all of the spectral movement in this simple sound is the result of the morphing filter sequence. To control the sequence with a modulator, ensure the filter morph target is set to the appropriate fseek1 or fseek2 value, and the morph amount is any value except for 0 so that you can hear the morph sequence. Then select Modulated for the sequence mode. Finally, you must route a modulator to the appropriate spectral sequence in the modulation matrix. In this example, I've created a custom shape for LFO1, which I'm going to use to drive the filter morph sequence. Finally, I'm going to route LFO1 to filter sequence 1 by 100% in the modulation matrix. On completion of editing, the Home button in every screen always returns you to the editor's home page or splash screen. Take care to save any edits you want to keep by saving the patch.